swaying like the children, single out for praise, inside out only open, with the straightest face, as a side woman spoke weakness you to hold me in the half light. Won't you hold me slowly in the half My mind can be so unkind. It's getting hard to sleep at night when there's no comfort inside. You're so psycho, sorry eyes. I feel better in the half light. It's like I'm healing for the first time. The sun is setting as the pain subsides. The colors cover me. Want you to hold me in the half light. Won't you hold me slowly in the half light. Want you to hold me in the half light. Won't you hold me slowly in the half light. Won't you hold me in the half keep on bleeding through the long nights. That's right, all night. Lord, I've got nowhere else to go. Place to go and ignore. All of my life I've been told wrong. I know you're waiting for the daylight, alright, so am I. Oh, 'cause without it I don't know. Love is unlimited gold. No, it's an open-end resource. Aren't you really gonna be fine? Think twice, so fine.
Good morning, everyone. Good to see everyone here. We got 16 people in. Good morning, Samantha. Good morning, Angela. Good morning, Olivia. Hopefully, everyone had a good long weekend, right? But regardless of you having a good long weekend, hopefully, you had finished your homework. That's the important part. Did you finish your homework? Okay. Good morning, everyone. All right. So, once again, hope you had a good long weekend. There wasn't too much happening overall. I had a good long weekend. Hopefully you did as well. And hopefully you did your homework that I asked you to. It was one question. And if you don't remember, well, I'll bring it up in a second. We're also just going to wait around 3-4 minutes to get some people in here. Because right now we got around 17 people watching. We'll wait until we get around 3 to 5 more people. Because this is supposed to be 2 classes put together. So we're just going to wait a little bit before that happens. Okay. Because we got people still coming in and out, in and out. Everyone doing okay with the quarantine still? You still got, well, assuming school's on time, we still got 3 more weeks of this online stuff, you know? We got this week, we got next week, and then the week after. And then, possibly, we go back to school. Good morning, Christian. Good morning, John. I see everyone else here with all the messages. Angelo, Tristan, Russell, Antoinette, Aaron, Julia, Angela. Just 2-3 more minutes and then we'll get started. Oh, let me go close my door real quick. I don't want that open. Morning, Andrea. So blank notes is like the notes that are empty, like there's nothing on it, it's a blank page. So like that's what you should be printing out and following along with and filling in yourself. That's what blank notes are. Good morning, good morning. Just waiting for a couple more people before we start, and then we'll get going from there. Morning, Amir. Morning, Mira. Morning, Nathan. There we go. We got much more people popping in right now. Guys, you can't even come on time for an online lesson. Come on. It's 11 a.m. It's even later than our actual class time. And you're at home. You have no excuse. Good morning, good morning. All right. I think we have most of our people here. Once again, if you still know people who don't have access to our Google Classroom or our YouTube, like this YouTube channel, please let me know, or please let them know, like the link in the Google Classroom code and stuff like that. When is the quiz or the test? Yo, someone tell Samandra when the quiz or the test is. I swear. Everyone should know when the next quiz is. Everyone should know when the next quiz is. If you know when the next quiz is, type in the chat right now. So let that be a lesson. Right? You should know when our next quiz is. Okay? Once again, if you don't know, where do you go? You go to the end of the previous video that lets you know, oh, those are the announcements. It's not hard. You can't just come and ask me those questions anymore because you have videos, right, from previous days that you can go back and look at. All right. So, let's get started with today. All right? So, let's take up the homework first. Okay, let's take up this homework first. This was the question we did on Thursday. So before the long weekend, we finished this question right here. Okay, this is the question we were supposed to do. I gave you the answer, and you were supposed to finish the question. So let's take up this using our substitution method for solving linear systems, and then we'll move on to the new lesson. And then I'll have a new announcement for you all. Okay? So, let's talk about this. First, let's go over what we've already kind of talked about with this question. Okay? So, the base idea we've had so far, right, is that the equation, okay, that we had, or the two equations that we had specifically, were these. Okay, so I gave you this to work with. 3x plus y equals 155, 2x plus 3y equals 220. That's what we started with, and I gave you the answer that you should already be looking for. Okay, so that being said, if we try to solve this, first step is to isolate. We look for a variable that has a coefficient of 1. In our case, this y here has a coefficient of 1, which means we want to make this y alone. So we're going to move the 3x to the other side. Move that there. And that's going to give us our third equation. Okay? So there's our third equation. Once we have our third equations, we've done step 1, which is to isolate. Step 2 is to substitute. So we're going to sub. We're going to sub 3 into 2, right? So we're going to plug in this equation into our second equation here. So wherever we see a y, we're going to replace that y in that equation with this part here. So we are going to get 2x plus 3 bracket 155 minus 3x equals 220. Okay. So 2x plus 3 times 155 times negative 3x equals 220. So we get 2x stays the same plus 3 times 155. Okay. 465 minus 9x equals 220. Okay. Then we continue collecting like terms. We get 2x minus 9x, which gives me negative 7x plus 465. It's equal to 220. And so that was step 2, which is substituting. Step 3 was to solve, right? We need to solve for our variable x. So let's do that, okay? So solving for x now here, we're gonna move the 465 to the other side. So we're taking this here, moving it to the other side. Wow, I cannot write today. Long weekends making me tired. Okay. I believe should be negative 245. Okay. Then we divide by negative 7 to get rid of it. And we get an answer of 35. Well, for x, that is, which was our basketballs, the amount of basketballs they bought, or the cost of one basketball. Then, once we have that, right, we can use that. Let's bring it over here. This x will go into our next step, step 4, which is sub x equals 35 into, we'll plug it into 1, the original equation. So we get, the original equation was 3x plus y equals 155. And we're going to replace this x with 35. So 3 times 35 plus y equals 155. Multiplying this out gives me 105 plus y equals 155. Then we continue solving for y. 105 moves to the other side. So we get y is equal to 155 minus 105, which will give me 50. Okay. And of course, I'm going to skip over the check part because I gave you the answer anyways, right? This should have been your answer, where your POI is 35, 50. Okay, so I'm going to skip over the check step, which was step 5, mainly because we already I already gave you the answer last week. So here's your thing for today. Okay, so this is our review of our solving by substitution. So we've done this for 2 days last week, right? And so this is your review, right? Just remember, substitution, talking about, well, substituting one equation into the other, right? But you'll notice a lot of these situations, this is assuming that one variable has the coefficient of 1. If it has a coefficient of 1, yes, it makes your life easier, and you can move things around, and you can solve for and isolate that variable. But today, we're going to be getting into these situations, right? We're going to be getting into these situations where, what if the coefficient isn't 1? Right? What if the coefficient isn't 1? Then what are we going to do? Okay? So that becomes an issue, right? We can't substitute, or if we even try to isolate, we're going to get fractions. And I know, and you know, that you don't like fractions, right? We do anything and everything we can to not touch fractions. So if you have your blank lesson notes for today, please take them out. Okay. If you need to look at this sheet, just rewind the video. You can rewind the live stream, go back and look at it, right? You don't have to watch this like right on time unless you want to interact with me in chat. So just focus on getting your notes. Okay. So this is our new sheet for today. Okay. This is our new sheet for today. So this is solving by elimination. Okay, solving by elimination. So if you don't have this, please take this out. I'll give you a couple minutes to do so. When you're ready, type a G in the chat so I know that you are ready. All right, we got a couple people. There's only a couple. We still need a couple more G's in the chat before we can get started. So I understand that everyone's ready. Okay. Wait for a couple more people to get ready, and then we'll get started with this this lesson here. Yep, if yours is still printing, just type a G when it's ready, Tristan. Just type a G when it's ready. How could you type G before you print it, John? I said, do you have it in front of you? If you're ready, then press G. Okay. So I think most people are pretty much ready, and I know some people might not be typing because they might be on their phones instead watching the video, which I understand. So let's take it slow. Once again, if you're still printing, just rewind the video to where I start this sheet, and then you can just copy down the notes. Right? You should be able to rewind the live stream and watch what you've missed. Okay. All right. So, solving by elimination. So this is a situation where your coefficient in front of your variable is not 1. You can't isolate it nicely. If you try to isolate it, you're going to get a fraction. So let's go through the steps on understanding what's the difference between substitution and elimination. Okay? So, when we add these two numbers, right? 2765 plus 1948, or we subtract 7549 minus 3616, it's easier when you stack them, right? Doing this mentally in your head is not something we normally do, right? If I ask you to mentally do this, you're going to be like, and start thinking about it for a longer period of time. Most of the time, right? Usually, it's much easier if you stack them up. And the stacking up, right, what we're talking about here, okay, is this. And this is the math you've done before, right? Back when in elementary school, you talk about adding numbers like tens and then hundreds and then thousands, right? To do the mental math, it's kind of hard to just kind of think of it in your head unless you're, of course, you're able to do that. You've practiced your mental math enough. But for most people, this is the way it's much easier with, right? We add the two numbers. So 5 plus 8 gives me 13. We put a 3, we carry the 1. Then we add these two, right? 6 plus 4 plus the 1, right? So 6 plus 4 is 10, plus 1 is 11. We write down the 1, we move the 1, we carry the 1. And then we do 7 plus 9 plus 1, and so that's 8 plus 9 is 17. Move that over, carry the 1, and then 2 plus 1 plus 1 is 4. And there's our number. Okay? So adding this shouldn't be anything new to anyone in this course, right? This is something you've done before. It's much easier to add and subtract larger numbers if we stack them on top of each other and go down each number at a time, like each point, right? You do the ones, you do the tens, you do the hundreds, you do the thousands, and then if you have more numbers, so on and so forth. That's always easier. So if we do subtraction 2, whoops, I'm going to rewrite that. I don't know why I drew a giant line. All right, let's rewrite that over here. There we go. That's what I meant to write. Okay. So with this number here, how do you subtract? Does anyone remember? With subtraction, right? You look and you understand, well, going from left to right, we may need to borrow numbers, right? 9 minus 6 is 3. 4 minus 1 is 3. 5 minus 6 is negative 1. We can't have that. We're going to have to carry a 1 from the previous one here. So 15, right, minus 6 gives me 9. And then 6 minus 3 is 3. Okay? So we have our number here. Okay? So whether we do addition and subtraction, it doesn't change anything, right? With bigger numbers, it's usually easier to stack them. Now, this is also true for our polynomials. Okay? That 3 is really ugly and it's bothering me. Okay. So for our polynomials, if we're adding two polynomials, if you don't want to expand the brackets, you can actually stack them and add them as well. Okay, and this is assuming the number in front of the bracket is 1, right? So when we're adding polynomials and there's nothing in front of the bracket, we're just adding two groups of polynomials, you can stack them. So we can write the first polynomial down the second polynomial down, and this plus sign, which I'll circle in green, this plus sign is essentially like the addition sign for your stacking. Okay. So now, when we do this, we can just go 3x plus 2x gives me 5x. Then we go 2y plus negative 5y is negative 3y. So it's the same stuff, right? Whether we break the bracket and combine like terms, this is just another way of combining like terms, right? But the reason why we're going over this is because when we do elimination, this method is what we're going to be using. So we need to be comfortable with stacking our polynomials again. Okay? So, important note, we want to stack the x's on top of each other and the y's on top of each other so that they line up. We want them to line up, right? If we have an x on the left and then a y on the left for the second one, what's the point? The whole point is to stack the correct variables on top of each other. If you stack different variables, you know already you can't combine those terms because x is not y. The variable has to be the same. So we're going to make sure that we line up x's on the left, y's on the right, or if your y's on the left, you put the y's on the left, right? But make sure that all the x's are on one side and all the y's are on the other side. Okay? So that's important. So let's now go through our examples. Okay? So for our examples here, now let's do subtraction, or let's try subtraction here. Okay? 4x minus 7y minus 3x minus 2y. Okay, so we write it out. 4x minus 7y is our first one. Okay, our second one is 3x minus 2y. And we put our minus sign on the left, which is our minus sign here. Notice how I don't have to expand the minus inside. We don't do that for this stacking method. We just copy down the polynomials that are in the brackets, and we write that minus sign in the middle on the left side. That's our operation. Okay, let me zoom in a little so it's a little easier to see. Okay. So once we have that down, we can subtract 4 minus 3 gives me 1, which is just x. Negative 7 minus negative 2. Okay, once again, negative 7 minus negative 2 is not negative 9. It'll be negative 5. Okay. So there's our first one, right? Negative 5y. Our second one here, once again, we copy down. Negative 5x plus 3y minus, oh, oops, not minus that way. Negative 2x plus 8y, and then we have our subtraction sign over there. So ignore that. You don't see that. That's a boo-boo. Okay. Once we have that down, we do our subtraction. Negative 5 minus negative 2 gives me negative 3x. Then 3 minus 8 gives me negative 5y. Okay. So there's your method of subtracting and adding polynomials by stacking. Okay. So once you have that copied down, if you go to the next page at the top, okay, that is the wrong sheet here. you'll notice there are two examples that I would like you to do. So I'm going to put 4 minutes on the clock. Okay. I'm going to put 4 minutes on the clock and you can get started with these. Okay. So 4 minutes on the clock. It should start now, coming up on the screen. All right. Good luck. All right. So hopefully you're done. I got a lot of time for everyone. So let's take it up. I see the answer for the first question there. Right? Ilya's saying it's negative 5x plus 3y. That is correct. So let's go over. Hopefully this is what you wrote out. So writing out our two polynomials vertically, we get 4x plus negative 9x, which will give me negative 5x. 2y plus y, or 1y specifically, would give me positive 3y. So there's our first one there. Okay. The second one, negative 3x minus 5y minus 7x plus 2y. Okay. So hopefully for this one you got the right answer here. We got a couple people writing it down, so that's good. So negative 3x minus 7x gives me negative 10x. And then negative 5 minus positive 2y gives me negative 7y. Okay, so yes, Christian and Ilya both got it right there. Hopefully you did as well within your worksheet there. If you didn't, copy down the right answer. Hopefully you're copying down with pencil so that you can erase it if required. Okay. Perfect. Very good, very good. So, just sliding down just a little bit. I'll keep that on the screen for people who are copying. The next question was, how would you make the following equal to 0? Would you add or would you subtract? Okay, would you add or would you subtract? So, over here, for the first one, if you get 3x and 3x, would I add or would I subtract to make 0? Add or subtract if you have 3x and 3x. No one has any ideas? Nothing in the chat? Perfect, we got our couple answers starting to trickle in here. Yes, subtraction, minus, absolutely. Good. So we would subtract here. Right? If we want to make 0, 3x minus 3x would give us 0. Okay? So let's go through each one of these. For number 2, negative 5y and 5y, right? If you have negative 5y and 5y, add or subtract. This would be addition. Good. We have the answers trickling in now. And I think people are getting the idea. That's very good. Okay. So people are understanding. Oh, okay. So here, for the next one, this would also be adding. And for the last one, it would be subtracting. Okay. So these are the 4 things. If we're trying to make 0, right? If we're trying to make 0, we need to do the following, right? For each one of these situations. So how can we summarize all of this? Well, to make a term 0, okay, looking at our little 4 examples here, if the signs are different, then you add, right? So for example, our negative 5 compared to positive 5. If we're trying to make it 0, we add them, right? Same thing here, positive 12 and negative 12. We add them to make 0. For our second one here, if the signs are the same, then subtract. to make 0. So if we're looking at 3x and 3x where they're both positive, we subtract them. And even if they're both negative, like negative 100 and negative 100, we would subtract them to make 0. Okay, so this is an important rule here. Okay, this is a very, very important rule. So let's go to this last part here before we jump into our example of what it means to eliminate to solve our linear system. Okay, in math, the word elimination means to get rid of. Okay, in math, the word elimination means to get rid of, right? To eliminate a variable by adding or subtracting two equations. Okay? So we're getting rid of it by adding or subtracting these two equations. All right? Perfect. So let's move on here. Let's move on. Once you have that copied down, let's go to our third and final page for today. So we have our two examples. Of course, you should already know the idea of how I'm going to do this. Example 1 is going to be with me. I'll be going over the example with you. Example 2, you will do it yourself. Okay? So let's go through example 1. First off, we're going to do step 1, which is to stack the equations. So we're going to S stack. Line up the equations x over x, y over y, and the equal sign over the equal sign. So this is what it's going to look like. Okay? I write the first equation down. I write the second equation down. Okay? Now, notice how I have not written my plus or minus sign over on the very left. That tells me which operation I'm doing. The way you decide, when you look at these two equations, which variable has the same coefficient? And in this case, it's my x. Both of my x's here have 3's, right? And they're both a 3. It doesn't matter if it's positive or negative. The number is exactly the same right now. Then we go back to what I asked before. To make a term 0, do I add or subtract? And our second line there, if I bring it back real quick. Okay. If the signs are the same, then we subtract. Okay? If the signs are the same, then we subtract. So, because the signs are the same, they're both positive 3, I'm going to choose it to be a subtraction equation. Okay? So I'm going to choose to subtract these two equations to eliminate the x. In other words, 3x minus 3x is going to give me 0x. Or in other words, it's gone. Okay? But I'm going to keep the 0x for now. I'll get rid of it on this next part. Then we continue. We go negative 4y minus 7y. Right? Negative 4y minus 7y is going to give me minus 11y. But we're not done. We now have an equal sign with some numbers on the right. So they follow the rule too. 14 minus negative 8. Okay? 14 minus negative 8 will give me positive 22. What this happens to be, because it's a 0x, this disappears. In other words, we will get negative 11y equals 22. Notice how the x is completely gone now. All right. So once again, this is elimination. We want to get rid of an x or a y. We want to get rid of one variable so that we can solve for the other. Okay. So that's our goal here. So step 3, we solve for the variable. So we have here negative 11y equals 22. And all you have to do is get rid of the negative 11, which we know how to do by dividing by negative 11, which will give me y equals negative 2. Okay. So I'm going to move down just a little bit here. So notice how, yes, elimination, setting it up might be a little bit complicated, but once you get used to it, you start realizing, oh, solving for the variable was very quick. It was fast. That was actually very fast. Okay. So now, substitute the value of the variable back into either of the original equations and solve for the second variable. So we are subbing in y equals negative 2 into any of the first equations. So what I mean by that here, just going to scroll up here, I can pick this one or that one and just pick the easier one. Doesn't matter. So I'm just going to pick the first one because that's the first one I see. Okay. So I'm going to sub. So I'm going to write down my first equation down. I'm going to sub in y into this equation here. Roy-san, just rewind the video so you can follow along. 3x minus 4 bracket negative 2 equals 14. So I'm just plugging in the y as negative 2. Okay. So 3x plus 8 equals 14. Now you've gotten to a situation where now you can solve for x using two-step equations. And so, moving the 8 to the other side, I will get 3x is equal to 14 minus 8. And that's going to give me 6. I'm running out of space, so I'm just going to write the answer down. And so x should be 2. Okay? So we plug in our y into our first equation and we solve for it. Okay, so now we have our hope to be answer. X is 2, y is negative 2. We have our x and y. So our fifth step, as always, is to check. Is it left side equals right side for both? Okay. So doing our first one here. 3x minus 4y equals 14. Our x is 2, our y is negative 2. Okay. Which gives me 6 plus 8 is equal to 14. 14 equals 14. Left side equals right side. That one's good. Our second equation is 3x plus 7y equals negative 8. 3 times 2 plus 7 times negative 2 equals negative 8. I'm running into the next spot. Whoops. Just going to have to do that real quick. 6 minus 14 equals negative 8. Negative 8 equals negative 8, which means left side equals right side. And we have our check mark there. Okay. Which means our POI is equal to 2, negative 2. Okay. So there's your answer there. So if you have any questions, please let me know. But otherwise, that's pretty much the idea. So I'm going to give you 5 minutes to solve the second example. I'm gonna fit this whole thing once again. At least I'm gonna try my best to fit the whole thing. Oh, almost there. It's gonna look a little small on your screen, but this is as best as it's gonna go. Okay, that's as best as it's gonna go to fit the whole first part, because it's a lot of steps. So I'm gonna give you 5 minutes on the clock. Do example 2. Okay, follow example 2 using example 1 as a guideline. So you're gonna get 5 minutes on the clock. Should pop up now. All right, good luck. Okay, so let's go over example 2. Okay, so there was a little bit of a trick, but really isn't a trick. But let's copy down. First step is to stack the equation. So we're going to write out our first equation. So x plus 2y equals 9. And then our second, we need to line up correctly. Since I wrote x first, that x should go first. So we're actually going to write 4x here, then write the minus 2y, and then equals the negative 4. If you did not line it up, that's okay, but it might make it a little more difficult to understand. Okay? So now we determine, okay, which variable has the same coefficient. Is it x or is it y? In our case, it's y this time, where they both have the number 2. But the difference is the signs are different. So if we go back to our previous page on making terms 0, if the signs are different, then add. So we're going to add these two equations. So 1x plus 4x gives me 5x. 2y plus negative 2y gives me 0y. 9 plus negative 4 gives me 5. Okay? So then if we continue, the 0y disappears, and we get 5x equals 5. We can then solve for our variable. I'll start zooming in now so we can see a little better. So since we have 5x equals 5, we can divide by 5 on both sides, and that will give us x equals 1. And I see some answers coming out on this on the chat, which is good. X equals 1 should be your first answer. Okay. The second one here, we plug in x equals 1 into our original equation. The first equation is easier than the second for this one. If you chose 4x minus 2y equals negative 4 to substitute into, you're all free to do so. But the first one has lower numbers to work with. So I'm going to use x plus 2y equals 9. And I'm going to plug in 1 as x and solve for y. Okay. So that gives me 2y equals 9 minus 1. 2y equals 8. And so in the end, y equals 4. So I rushed through that. I'm going to leave that on the screen for a little bit. So you should be able to substitute x equals 1 into any of your two equations. I chose the first one. And solve for y. And so I get y equals 4. Okay, y equals 4. So I'm just going to wait a couple seconds for people to finish copying down. Then we can check our answer here, but we are at the 12 p.m. mark. So I'm just going to write the answer for this one because I don't want people to overstay, and I do need to prep for the next class. You should know, and when you check your work, your point of intersection, your POI, is 1, 4. Okay? Make sure you use brackets and you use a comma to indicate that. Okay? So, that is our class for today. That was elimination. Now, some of you may be asking, Mr. Choi, what about the quiz? Blah, 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 blah. Well, that's the announcement for today. I'm actually going to push the quiz to tomorrow. So you're going to tune into my live stream. Okay? You're going to tune into my live stream. You're going to come in. I'll give you the link here. Right? I will have the live stream open. And right after the quiz, we're going to go over some more elimination problems tomorrow. So, Samantha, is the other pages homework? Yes, it is homework. However, I will be going over some questions, so you don't have to start the homework until tomorrow afternoon. Okay? This week, office hours will be on Thursday since we have the Monday off. So Thursday will be office hours. That's where you can ask about the elimination questions. Okay? And lastly, the Friday will be a new lesson. Okay? So Friday will be a new lesson. So tomorrow, the quiz, and right after the quiz, we'll be doing a short continuation of today's lesson, just looking over some more examples. If you have another class at this time at 11, the quiz form will be posted on Google Classroom. You must log in using your student email. Okay, you must log in using your student email, and then you can write the quiz. Okay, anyone who does not use a TDSB email, I will delete your quiz from my form. Okay, you must log in using your TDSB email. If you do not, I will delete your quiz. Okay, I don't care if you got all the answers right, 10 answers right, 5 answers right, however many questions there are, you must, okay, show me your TDSB email. Otherwise, that is it for today. Thank you so much for coming in, and those who came in on time, Roy-san. Thank you for not coming on time, Roy-san, and make sure you come on time, Roy-san. But to all of you, have a good rest of the day, and I'll see you tomorrow. Peace out.